Hello and welcome back to another episode of Math with Sohn. Today we are going to be graphing all the different types of parabolas: vertex form, factored form, and not standard form. So just factored and vertex, but we're also going to determine the domain and range given the scenario. So here, if we want to graph it, we have our vertex. This is vertex form. It would be at -2, -5. That would be our vertex. Okay? Versus over here, this would be factored form. All right? So if this is our vertex at -2, -5, for these problems, I'm not going to be too concerned as long as you get a vertex. That is the important part for these. That is the one that I want you to find. Then we're good to go for the graphing part. -2, -5 would be about here, and it would be facing up. Okay, if you want to, you could plug in 0 and get the y-intercept, which would end up being at -1. So I'm a little off with my graph. But what would the domain and the range be? The domain is all real numbers because it goes left and right forever. But the range would be y is greater than or equal to the -5 because that is where the y value of the vertex is. All right? Number 2, we also have vertex form. It's shifted up by 5. So if we change the sign, keep the sign here, you get 0, 5 for the vertex. And it would be facing down. So 1, 2, 3, 4, 5. It would be a downward facing parabola because it is negative in front. So it would be going that way. And then we have our domain and our range. Our domain is still all real numbers. Our range would be y is less than or equal to the 5 because it's going down from the 5, not up. And lastly, number 3, this time if we change the sign and keep the sign, you change the -3, you keep nothing. There's nothing to keep, it's a 0. And then this would dictate that it would be facing up. Now because there's a 2 there, I am going to maybe plug in a point to see what's going on. So we got a graph at 3, 0, 1, 2, 3, 0. And a little trick for your teachers to never know is that the very first point mimics the slope for a parabola as long as it's a whole number. If it's a fraction, it doesn't really work that way. It can't go up by 1 and over by 2. So for here, because this is 2, it's going to end up being skinnier because we're going to go up by 2 and over by 1, and up by 2 and over by 1. It's going to be a slightly skinnier parabola than it would have otherwise been. But again, I really just said that the vertex is the most important part, but this would make it stretch vertically by a factor of 2 as well. The domain is all real numbers. The range is y is greater than or equal to 0 because it's going up from the 0. Okay, factored form. This form, even though you have factored in the past, is going to be the unique form for graphing for you guys, okay? So you can find the zeros. X will equal, change the sign 4, change the sign 2. Those are your two x-intercepts. So we're going to plot the point at 2 and plot the point at 4, okay? Now it will be facing up, but I don't know where I should put my dot here. Should it be way down here? Should it be way up here? I don't know where I should put my vertex to make it face up. Okay, I do know that my y-intercept is +8. If I multiply 2 times 4 is +8, but that's still not enough to figure out my vertex. Okay, so here's what you do. You know that the vertex is symmetrical. All right, all the way around the vertex is symmetrical, so we know that the vertex is going to be at 3, because if you look at the middle between 2 and 4, it's 3. All right? It's a little bit easier with graph paper to do, but you could also add up 2 plus 4 and divide by 2 to get a vertex value of 3. Once you get the vertex value as 3, then you can plug in the 3 to get the y value, just like we have done before in the past. So we're going to have 3 minus 4 and then 3 minus 2. If you've done it correctly, the vertex is always going to do something kind of cool. It's always going to give you the same number and then opposite signs. In this case, it's going to be -1 and +1, which ends up being -1. Now, if you were listening carefully to the slope is always the very next point, this one should have had a slope of up 1 over 1. So you should have known maybe it would be down 1 over by 1, and we would have that vertex at 3, -1 in this case. but most of the time you're not going to get that lucky. All right, because most of the time the vertex is not going to be 1 point away from those two x-intercepts, much like number 5 is going to be. So in this case, we have our x-intercepts at x equals 3 and x equals -1. You change the signs of everything in the parentheses. That -2 has nothing to do with that. We are going to plot those 2 points at +3 and -1. Then it's a little harder to see where the middle is, but the middle is going to end up being probably at 1, maybe 2. So let's add them up, -1 plus 3 and divide by 2. Well, -1 plus 3 ends up being 2 divided by 2 does in fact end up equaling 1. Okay, so now that we have that, we can figure out what the other values are going to equal based off of it, because we're going to plug in that 1. So we got the -2 in front, we got 1 minus 3, and then 1 plus 1. In this case, you end up with -2 times -2 times +1. Well, -2 times -2 times, did I say +1? Times +2 ends up equaling a +8. Let's make sure that that makes sense, because if we plot the point at 1, 8 way up here, will the parabola look right, knowing that it should have faced down with that -2? Yes. Okay. Is the y-intercept 3 times 1 times 2? Yes, it's at 6, which looks approximately correct as well. Okay, so there's another trick you could do. Multiply all the regular numbers, -2 times -3 times +1. That would tell you your y-intercept, which isn't the important part, but it is a way of checking your answer. Next one, and last one. Here we get x equals 0 for this part, because you could set your factor equal to 0, and x equals 5. All right? So if we plot the point at 0 and 5 here, and here at 5, and we graph it facing upward, we need to find the vertex. But in this case, if we add 0 and 5 and divide by 2 to get the midpoint, you get 2.5, or 5 over 2. That's annoying. Okay. 2.5 for the middle. But if we plug in 2.5, it won't be the end of the world. We get 2.5, and then 2.5 minus 5 ends up equaling 2.5 times -2.5, which that's a number that is 25 over 4. 25 divided by 4 is something. 2.5 times 2.5 ends up equaling 6.25, -6.25. So if we plot that point at -6.25, way down here, we get our parabola. Okay. Next part of today's lesson is going to be using key features provided to write the equation of the quadratic function. So you can have one of two things provided to you. You're going to get the vertex form or the factored form. In both cases, they're going to always give you some other point on the parabola. So in this case, we have vertex form. So we have y equals a, change the sign, x minus 2 squared plus 8. Okay, so change the sign, keep the sign. The reason I wrote a here is we don't know how skinny or how wide this parabola is. However, that is what the point is for. You plug in the x and the y values and you solve for that a. So you start it the exact same way, recognize that there's an a there, plug in the point. -1 would equal a. 3 minus 2 squared plus 8. Here's the mistake a lot of people make. They decide to forget to write the squared, or they decide to square before they subtract or add these things. I don't know. -1 is equal to a. 3 minus 2 is 1 squared plus 8. Let's solve for a. We're going to subtract the 8 over. That makes -9 is equal to a times 1 squared. Square, and you get -1 is equal to a times 1. Divide by the 1, a would equal -9. Now, most people think they're done here. But remember, the equation is not this. The equation would be everything that we had here before we didn't have the a value. So we're just going to plug in that a value, you get -9, and then the x minus 2 squared plus 8. A lot of times what I do is I just rewrite it right there, and I just replace the a. All right? Number 2 is going to be in factored form, we have the x-intercepts are 3, 0, and then negative 5, 0. So that is going to be y equals a, change the sign, and then change the sign. Pretty much anything in factored form, you got to change the sign. Plug in the point on the parabola for x and y, so negative 6 equals a. This is going to be 2 minus 3, and this is going to be 2 plus 5. Now, the trick is not going to work here. If you're freaking out like, whoa, these aren't going to be the same number, that's because this is a point on the parabola, not the vertex. You get negative 6 equals a, negative 1 times 7. Well, what's the a value going to be? It's going to be negative 6 is equal to a times negative 7, so we divide by negative 7 and get an a value of 6 over 7. Because they're both negative, ends up being positive. We have our a value, plug it back into the original, y equals 6 over 7, x minus 3, then the x plus 5, get your final answer, and get the question right. All right, last two, everybody. This one is factored form because I didn't click the dot for our vertex. So we have our factors at x minus 1 and x minus 3. You just change the signs. And then you have your y-intercept of negative 3. Negative 6. I don't even know what I'm talking about. So we have a, and then this equals y. All right. We're going to plug in this point, 0, and then negative 6 for y, to solve for a. So this is 0 for x, 0 for x, and then negative 6 for y. Solve for a would equal 0 minus 1, negative 1, 0 minus 3, negative 3, and then that would equal negative 6. You get a positive, not 4, scribble out, a would equal positive 3 equals negative 6, a times positive 3. Divide, and you get a equals negative 2. Plug in the a. Don't forget to plug in the a. Negative 2. Change the signs of both of your x-intercepts. Get your answer. All right. So, here, you have a vertex. 3, negative 5. You have a solution. Kind of. 5.236. And you have another point, 0, 4, the y-intercept. So I'm going to plug it in vertex form because I have the vertex. Y would equal a, change the sign, squared minus 5. So we got to change the sign, keep the sign. Let's plug in this point. You could plug in either of the points, but why would we plug in the nasty point? Let's plug in this point, 0, 4. 4 is y, a, 0 minus 3 squared minus 5. We are going to subtract the 0 minus 3. You get 4 is equal to a, negative 3 squared minus 5. Add the 5 over. You get 9 is equal to a times negative 3 squared. Well, negative 3 squared is 9. And if we do 9 divided by the 9, you find out that the a value is 1. And you get your final answer of y equals 1, x minus 3 squared minus 5. That's going to do it for this one. Until next time, everybody, stay positive, and I will see y'all later. Bye.